Okay, friends, so the first thing we're going to do today is the warm-up, where I ask you to predict the charges of the three underlined ions here. So the first one that we have is a sodium ion. That one should be fairly easy to predict using your periodic table, which you should have out, by the way. Get that out if it's not out yet. The second ion I need you to predict the charge of is NO2. Now, NO2 might not be an ion that you've seen before. This is a polyatomic ion, closely related to NO3 1-. Remember this from our polyatomic ion video. We've seen this one a bunch of times, nitrate. This is not nitrate, but it is nitrite. But you don't need to know that in order to predict the charge of that ion. You don't need to know the name of it. And the last one that I want you to predict the charge of is HPO3. This one you definitely haven't seen before. I'm not going to tell you what this one is called. I'll tell you later, just to really hammer home the fact that you do not need to know, you do not need to recognize these polyatomic ions in order to guess the charges, because we have enough information to do that. So pause the video, give it a try, and then play, and we'll go through it. All right, so the first one here, Na2S, I can predict that charge fairly easily because I just need to look at the periodic table. And that'll tell me right away that my charge here is +1. I have a +1 charge on my sodium ion. That one was very straightforward. Not a whole lot of thinking had to go into that. The next one, though, remember I said this was called a nitrite ion. And I can figure out the charge on my nitrite ion by thinking about the charge on my magnesium ion. I know that magnesium is going to have a +2 charge, and I also know that in any ionic compound, the total charge of my my cation plus my anions, it's always going to add up to 0. So then I know that this, I know that this whole charge, this whole thing, is going to have a charge of -2 to cancel out that +2 from the magnesium. But then how many nitrite ions do I have in this compound? I have 2. So then each nitrite must have a -1. Each nitrite must have a -1 charge if we want our overall compound to add up to 0. Because now my 2 nitrites together make a -2 charge, and that -2 charge can cancel out with my +2 charge for my magnesium ion. So if you weren't able to get that one, you probably weren't able to get the third one either. But now that you've seen, try it again. Pause the video and try K2HPO3. Try to figure out the charge on that polyatomic ion. Okay, so we're going to do the same thing that we did before. We're going to use our known charge. Right? We know the charge on a potassium ion. We're going to use that to figure out what the charge is on our HPO3. So our K2, or sorry, our K is potassium, and a potassium ion is always going to have a charge of +1. It's always going to have a charge of +1. But since I have 2 potassium ions in this case, the overall charge on the first half of my compound, or the first half of my formula, is going to be +2. Those 2 potassium ions come together, add up to a +2 charge. And that's how I know that the second half of my polyatomic ion must have a -2 charge, because those need to cancel each other out. And so that's how I know that my HPO3 ion has a -2 charge. If you got caught up and you were thinking that this 3 was ruining things, and you wanted to divide that -2 by 3, and it was getting real confusing, you do not need to do that, because remember, this 3 is telling us that we have 3 oxygen atoms in this ion, right? So really, this, like if I wanted to draw this out, I could say there's my 2 Ks, and here's my 1 HPO3, right? And those bond together to form our ionic compound here, right? And inside that blue dot here, that blue circle, that has our H and our P and our 4 O's, right? Obviously, that's not the structure of it, but it has all those atoms in it. Sorry, that really should have been only 3 O's. Sorry about that. There we go. So if you were confused about that 3, that's what's going on there. That 3 is part of the polyatomic ion. And you'll get better at recognizing those polyatomic ions when you see them. Okay, so that's that. That was the warm-up, and we're going to use the warm-up. We're going to use that same kind of thinking right now in the first page of our notes. So I need you to get your notebook out, and we're going to take notes on ionic compounds, containing transition metals. And the first thing I want you to write in your notes is that transition metals, unlike other elements, do not have predictable charges in ionic compounds. So remember, sodium, for instance, or potassium, or lithium, rubidium, all of those first column elements in the periodic table, they're always going to have a +1 charge. Everything in the second column is always going to have a +2 charge, right? There's a predictable pattern there with all the other elements that form ionic compounds. But transition metals are a little bit different. There's no pattern there. So to figure out what the charges are on some of the transition metals, I'm going to ask you to draw this table. I want you to write this table like I have it. Copper, cobalt, nickel, and iron. It's just a handful. And we're going to see if we can, figure out any patterns. Maybe there is a pattern and we just have to work really hard to see it, right? And the way we're going to do this, we're going to have a column here, so call it charge. And then we're going to look at some compounds, some ionic compounds that include copper, some that include cobalt, nickel, and iron. And we're going to use that same kind of process that we were doing here in the warm-up to figure out what the charges are for copper ions, cobalt ions, blah, blah, blah. Okay, so let's jump right in. Let's do an example here. We're going to be coming back to that table again and again. The first one I want to do is CuNO3. And what I want you to do is I want you to tell me the charge on this copper ion. So pause the video now and take a stab. All right, so we should have been able to find NO3 on our polyatomic ion sheet or in our notes, and we would have found that to be nitrate. And I know that my nitrate has a charge of -1. And so we can use our reasoning from before that if we only have one copper ion to pair up with that nitrate ion, that copper ion must have a +1 charge because our charges here need to add up to 0. So there we go. Copper has a +1 charge. So let's add that to our table here. Copper has a +1 charge. And we can move on to cobalt. For cobalt, I want us to look at COF. Let's try that one. All right, so F is fluorine, and when that's in a ionic compound, we call it fluoride. Fluoride has a charge of -1 because it's in the 7th column of the periodic table. And cobalt then, since we only have one cobalt ion, must also have a +1 charge. There we go. Pretty easy. So cobalt +1 charge. Let's do another one. Let's try Ni, hello, NiSO4. Ni is nickel. Look on your polyatomic ion sheet, wherever you have that, look for SO4. You can get the name and the charge. Okay, so SO4 has a -2 charge. This is a sulfate ion. Like I said, you'll get better at recognizing these. You do not need to memorize them. Remember, you're going to have that list. And so how many nickel ions do we have here? Just one. And if we need to add up to 0, then that's going to be a +2 charge. Some of you might be asking by now, why didn't we multiply this 4 by this 2 to get a total charge of 8? Well, because remember, this 4 goes with the oxygen. It's telling us that we have 4 oxygens in this sulfate ion, but it's not telling us that we have 4 sulfate ions. That -2 charge doesn't live on the oxygen. It lives on the sulfate, right? This sulfate ion has the charge. So we would need multiple sulfate ions if we wanted to get more than a -2 charge on here. The only way we would have a -8 charge is if we had SO4 parentheses 4, and then the thing outside the parentheses would be multiplied by the 2. Okay, if you weren't wondering that, sorry, tangent. So there's nickel sulfate. We can add to our table that nickel has a +2 charge. And if you're looking at your periodic table and trying to discern any kind of pattern, you might be having a difficult time. And so, maybe there really isn't a pattern. Hold on, I want to try this one. Let's try CuCl2. Try that one. CuCl2. I want the charge on this copper ion. And while you're at it, why don't you try the charge on that copper ion as well? All right, so check it out. On our chloride here, we have a -1 charge on one chloride ion, but we have 2. So then that's a -2 charge. So we have one copper ion. That must be a +2 charge on our copper ion. But then over here, we only have one chloride, and this compound apparently still exists. So here we have copper with a +1 charge, and here we have copper with a +2 charge. That's weird. So can copper do multiple charges? It turns out that it can. Copper can do multiple charges. And by the way, guys, cobalt can also do multiple charges. Nickel can also do multiple charges. So this was a ruse. I'm sorry. You didn't actually need to write that. If you did write it, you can draw a line through it. And instead of that, I want you to write all transition metals can actually have multiple charges. All transition metals can actually have multiple charges. And so this presents a problem, right? Because what we haven't talked about yet is naming these compounds. Now, we would think, right, that they follow the same naming rules as all the other ionic compounds that we've looked at so far. So if I wanted to name CuCl2, for the first for the first piece of our formula, we just put the element name, right, copper. And then for the second part, we put the element or the ion with the "ide" ending, right? It's copper chloride. But if we were going to follow these rules, then both of these compounds would have the same name. And that is a big problem. Because let's say that we were working in a lab, and I had hired you to work in my lab, and I was telling you to, oh, can you grab the copper chloride from the cabinet, and we're going to use, I need you to measure out 16 grams of that. If you were going to do that, how would you know which copper chloride to grab? Because, I mean, I'm going to have both. It's a well-stocked lab. I'm going to have CuCl2, and I'm going to have CuCl. So how are you supposed to know which copper chloride to grab? Well, they need to have different names, right? Because I'm going to call it by its name. I'm not going to say, I'm not going to sit there and tell you to grab the CuCl2. No, I'm going to say copper chloride. I'm going to say whatever its name is. And so the name for CuCl2 is actually copper, parentheses, II, close parentheses, chloride. And that II, those are Roman numerals. Sometimes you will see them capitalized, like that. But lowercase is fine. I don't care. That's a Roman numeral for 2. This one is called copper I chloride, or copper 1 chloride. That's really how you say it, copper 1 chloride and copper 2 chloride. Now I want you to think for a second, what do you think what do you think that number in the Roman numerals, what do you think it represents? Now, a common thing to think is that this 2 represents that 2. It tells us the number of chlorides that we have, or the number of chlorides that we have here. And that's totally understandable. I could see why you'd want to say that. But actually, it represents the charge on our copper ion. And it's not always going to work out that those happen to be the same number. Okay, so you do need to learn this. You do need to know, and I want you to write this down, that 2 represents the charge on copper ion. Because you have a positive 2 charge. And this I over here represents the charge on the copper ion as well. Some people were asking me today, what if it's a negative charge? Well, it's never going to be, because I'm only ever going to put Roman numerals after one of my transition metals. And all of my transition metals are only ever going to have positive charges. So I don't need to put Roman numerals over there, because guys, chloride always has the same charge, right? Remember, that's the whole reason that we need to put the Roman numerals, is to communicate something. We're communicating what charge the copper ion has. So for anything that can only do one charge, the Roman numerals are pointless. They don't serve any purpose. Okay. So there is that. Let's do a couple of more examples. Or actually, what we should do is we should name the other 3 compounds that we've written here. Why don't you take a stab at that? So write names for these 3 ionic compounds using the Roman numerals. Pause the video now. Okay, so this is copper 1 nitrate, because 1 represents the charge on our copper ion. COF, this is cobalt 1 fluoride, because our cobalt ion here has a charge of +1. And this is going to be nickel 2 sulfate. Nickel 2 sulfate. Because nickel has a +2 charge. Okay, let's do one more. Or we can do a couple more. Let's try FeBr2. Tell me the name of this compound. Pause. All right, so before we can tell the name, we need to know the charges on these ions. I know that my bromide is always going to have a -1 charge because I know what column of the periodic table it's in. But I have 2 bromides. So overall, I have a charge of -2 on the second half of my ionic formula here. So that must mean that my iron ion, since I only have 1 iron ion, it must mean that I have a +2 charge on my iron ion. So then if I'm going to write the name for this, this should be iron 2 bromide. Why don't we try one where we have multiple metal ions? That'd be better. Okay, let's try, this is a good one, Ti2s. Try that one. Okay, let's try it. S is sulfide. I know that has a -2 charge because I know what column of the periodic table it's in. And so overall, this first part of the chemical formula must have a +2 charge. But I noticed that I have 2 titanium ions. So then what is the charge on one of those titanium ions if the overall charge is +2? Well, it must be +1. It must be +1. One of my titaniums has a +1 charge. And because I have 2 of them, that adds up to a +2 charge, which is how I cancel with my -2 charge on my sulfide. So when I name this, this is going to be titanium 2 sulfide. Oh my goodness, I made a mistake. Right, because remember, this Roman numeral, my mind was wandering, sorry. This Roman numeral is supposed to represent the charge on 1 titanium ion. So this should be not titanium 2 sulfide, but titanium 1 sulfide. I'm so sorry about that. If you caught me, good job. You're doing good. Okay, the last one I want to try as a group before we go to the packet for more practice. Let's do iron, let's do Fe3O2. I want the name of this. This is the hardest one we've done yet. I'm sorry. If you tried that one and you got confused, that's my bad. This should have been Fe2O3. Fe3O2 would have been really difficult to try to figure out. Try this one now. Sorry about that. Okay, so one of my oxides is going to have a -2 charge, but I have 3 of them. So overall, I have a -6 charge on the second half of my ionic formula here, -6 charge. That must mean that overall, I have a +6 charge on this first half of my ionic formula. But I have 2 irons, adding up to a +6 charge. So then each iron ion must have what charge? That's right, it should have a +3 charge. Because then my 2 +3s add up to a +6. That cancels with my -6 from the oxides, from the 3 oxides. So then the name for this one is what? That's right, it should be iron 3 oxide. Iron 3 oxide. That's how we name that one. Okay, so I'm going to set you loose on the on this page of your packet, ionic compounds containing transition metals. And you can see that the first 8 are going to be giving you the name, and you have to write the formula. which might be a little bit easier than the other way around. But this is going to require you to look back at your polyatomic ion sheet, right, to figure out what is sulfate, what is cyanide. If you get stumped, if you're looking for hydroxide and you're like, where's hydroxide? And you're looking all over the periodic table and you can't find it, it's a polyatomic ion, right? If you can't find, if you don't recognize an ion name, and you're like, that doesn't sound like it's an element, look in your polyatomic ion sheet. You probably want to look there first, honestly, for anything you don't recognize, because it's a smaller list. Remember, your polyatomic ion sheet is in this packet. It's all of these, plus chromate and bicarbonate. You need those two on the polyatomic ion practice right here. Oh, one more thing. When you get to 5 and 6 on this page, you'll notice that silver and zinc do not have Roman numerals after them. So you might be thinking, how am I supposed to know the charge of a silver ion? Well, you're supposed to just know that silver always has a +1 charge, and zinc always has a +2 charge. Remember that the need for these Roman numerals was based on their, like, chromium can do multiple charges, cobalt can do multiple charges, copper can do multiple charges. That's the whole reason we need to put the Roman numerals in there, right? So that you know which jar of copper chloride to grab when someone tells you, right? You can be told copper 2 chloride or copper 1 chloride. We don't need those Roman numerals with ionic compounds containing silver and ionic compounds containing zinc, because they're always going to have the same charge. Silver is always going to be +1, zinc's always going to be +2. So that's why we don't have Roman numerals in there. And I do need you to know that for the test. You don't need to memorize it. I'm going to ask you to add that to your periodic table. Why don't you do that now? So on your periodic table, I need you to put +1 in the upper right corner of your silver box and +2 in the upper right corner of your zinc box. And then in the bottom left corner, I want you to write what I have here. This is telling you which elements in the periodic table have multiple charges. So remember, that's going to be all of your transition metals, plus, actually, lead and tin, because lead and tin are not transition metals, right? Those are just like other metals. Remember, if you colored your periodic table, you would see that. So it's all transition metals plus lead and tin, and except for zinc and silver, which always are going to have the same charge. Okay, so try these. Work through this sheet. The key will be posted sometime this week, sometime soon. Yeah. Thank you for watching. Hopefully that was helpful.